Well, hello, folks. Hope you all are doing great, and welcome to one more video in our Java for Beginners tutorial series. Today, we are going to understand what are the different data types in Java. And before we jump into what data types are, basically, we have to understand one specific thing about Java is that Java is a statically or strongly typed language. So, what that means is whenever we are going to use a particular variable in data, we have to declare what kind of data you are going to store in that variable. And the way to do that is to create a variable with a particular data type. So type of data can be multiple. It can be a boolean data, that is basically true or false. It can be a character data like a, b, c and all. It can be a numeric data like your floating numbers 1.23 or integers like 10, 12, 13, or it can be raw data as well. Raw data in the sense whatever you shoot on your mobile, whether it is pictures, whether it's audio, whether it is video. So these kind of data demand special kind of processors, and those are called raw data. So today we will see how we can store different kinds of data and how we can declare variables with this specific data type so that we can use them meaningfully in a program. So without much further ado, let's quickly jump into today's lesson. So here what we can see is the different types of data types that are possible in Java. So it can be broadly categorized into primitive types, then derived types, and user defined types. So coming to the primitive types, these are basically not objects. These are very native to the machine that you are using, and these basically has something called wrappers that we will be discussing in a future lesson on how we can create objects, create wrappers on top of these to make them behave more like Java objects. So what kind of data we are talking about here? It can be a boolean data, which is basically a true and false value. Then we have integers. Integers can be classified further into character, byte, short, integer, and long. Then we have floating point. Floating point is any number with a decimal value with a fractional component to attach to it, and they can be broadly categorized into two different data types, which are float and double. We will be seeing in much more detail what these data types are, what are the maximum possible value, what is the minimum possible value that you can store in these data types. Now coming to the derived data types is something that can store a particular specific type of data in a multiple fashion. So let's say I want to store hundreds of integers. So how we can do that? We can do that in an array. If we want to store hundreds of characters, how we can do that? We can create a string of all those characters. So we will be discussing in much more detail how string and array can be created and all in future lessons. And now coming to the user defined data types. User defined data types are custom data types which we kind of define based on the requirement that we have at hand. So let's say we are modeling a particular data that needs storage, and for that we feel that okay, we should be using an array, we should be using a string, we should have integer as well. So basically it's a composite of all the types that we discussed thus far. So how we can do that? We can do that using by creating classes, by creating enumerations and interfaces. So these are a bit advanced concepts that we will be touching upon in one of our future lessons. So next what we are going to see is what are the data requirements, how much storage this data type kind of uses, and what are the minimum and maximum possible values that each of these data type can allow you to store. So here we can see there are three columns basically. So one is the data type column. Next is how many bits or bytes it needs to store the data, and the range of values that we can store. So let's say I want to store a true or a false value. So I will declare my variable as a boolean type, and a boolean type needs just one bit. It does not even need one complete byte. One complete byte is composed of 8 bits. And what are the range of values? Since it's a binary in nature, it will store a true or a false value. Moving on, we have a character data type, and character data type stores data in a specific format called as Unicode. This is kind of out of scope of this discussion, and we will be discussing what Unicode characters are in a future lesson. But for now, it is sufficient to say that Unicode requires 16 bits of storage, that is 2 bytes of storage, and it stores data starting from U4 zeros to U4 Fs. So this is a Unicode representation. It's a bit advanced. I'll try to create a separate session to make you understand what Unicode characters are. Next, moving on, we have byte. Byte, as the word says, it needs 1 byte to store the data, and it stores specifically signed integers. And by signed integers, we mean the signed representation of a number. So 1 bit of the entire data is reserved for the sign, whether it is positive or negative. That's why we get to store one less value in that particular representation. So that's again advanced concept. So for now it is sufficient to say that it stores minus 2 to the power 8 to 2 to the power 8 minus 1 values. And why 8? Because it needs 8 bits to store the data. Moving on to short. Short is a bit higher in storage capacity than the byte. It's almost like double. So it requires 2 bytes of data, and the range of values that it can store is minus 2 to the power 16 to 2 to the power 16 minus 1. Moving on, integer needs 4 bytes, and it needs minus 2 to the power 32 to 2 to the power 32 minus 1. Again, how we are getting this 32? Just multiply 8 by the storage requirement. So 8 into 4 is 32. So we immediately know that 32 bits are required to store this information. Moving on, long. Long is again an integer data type, and it needs 64 bits to store the data, which is 8 byte. And the storage capacity is really huge. It is minus 2 to the power 64 to 2 to the power 64 minus 1. Now moving on to numbers which has fractional components or decimal point, right? So we have float, and float again needs 4 bytes of storage, and double, it needs 8 bytes of storage. So there is a precision component. Precision means the fractional part that we are going to store. So that precision component is actually defined in the number of bits, and it's a bit advanced how float and double is kind of stored within these 4 bytes and these 8 bytes, and would need probably another session to kind of discussing this particular point. So I'll kind of refrain from explaining how float and double are actually stored internally in memory for a future lesson. Okay. So that's pretty much about it. So the next thing that we are going to cover is to show you in code what is the maximum and the minimum possible values for each of these data types we discussed thus far. So here basically we have defined a class called data type. It has one specific method, the main method, and in that let's see what we have to do. So we have defined as well as declared a particular boolean variable in one single line. So this can be done. If you want to do it on separate lines, you are free to do so as well. So first of all, we have to use the keyword boolean, and then the name of the variable, then the assignment operator, and then we will assign the value. So here we are just printing out the value of isValid variable, and then we are reassigning the isValid variable to store true instead of false that we stored here, and then we are printing out the same. Now we have declared and defined a character data type. So we first use the char keyword, and then the name of the variable. This is totally user defined. Then the assignment operator, and then the value. So since this is a character data type, always remember that we have to put values in single quotes. If you don't use the single quotes, the number that you are going to assign to character will be internally treated as a Unicode representation of that character. So here I want this character to store the highest possible value that is possible in Unicode. Next we are printing out the character data that we created here. Next, before we start explaining what these lines are basically doing, the thing that I want to mention is there are primitive data types and there are wrapper classes available for the same data types. So when I say wrapper classes, what do I exactly mean? So let's say I have int. Int will have a wrapper class called integer in Java. So integer will help us in creating an object on top of that basic primitive type that we defined as int. So since there are 8 primitive types in Java, each of these primitive types have a wrapper class as well. So basically in these next few lines we are using the wrapper classes to kind of give us an understanding of what the primitive type, which is the underlying actual data that these wrapper classes are wrapping, what does it basically store. So when I mention character dot max value, that means I want to know what that primitive type char that we defined in line number 11 can store, what is the maximum upper ceiling and what is the lower ceiling of that particular data type. So keep that in mind and let's go through the next lines. So here we are trying to use the wrapper class of the primitive char data and we are trying to print the max and the mean value. Next we go to the byte primitive types wrapper class and we get the max and the minimum value which a byte can store. Next for short as well, we are printing out the max and mean value. Next we have integers and long, and both these statements are doing the same thing. They are printing out the max and the min value for its corresponding primitive type. Next, moving on to the precision data types, which has a fractional component. So those are basically two. We have float and a double. So float basically is having a max value and a mean value as well, which we can see once these two lines execute. Same for double as well. Double has a max and a mean value, and we will see what these values are when we run the code. So let's quickly run the code and see. So go to the method, towards the left side you will have a green arrow, click on that, run the code, and here we have the output. So as you can see, this is how the boolean values are getting printed. We are directly getting whether it's a false or a true. Then we are printing out a character, since we have stored /u and 4 f's that internally got represented in Unicode, and Unicode, that value actually equates to this weird looking character. Then we are printing out the max value of the character, then the mean value of the character data type. Same for byte, short, integer, long as well. Moving on to float, you will notice that both the float values look like they are positive values. The max value is of course a positive value, but how can a mean value be also a positive value? So if you look closer, you will see that these are exponential representation. So we have something called e to the power of 38 and we have something called e to the power minus 45. So e basically means 10. So 10 to the power 38 is the maximum possible value of float, and 10 to the power minus 45 is the minimum possible value. So you see the range is huge, and this is even higher, exponentially higher for double, because double is doing the storage in 8 bytes of data instead of float which just has 4 bytes. So in double you can see this number e to the power 308, that means 10 to the power of 308. That's a huge number. You cannot write that maybe, right? And the minimum possible value is also e to the power minus 324, right? So that's a huge range. So that's pretty much it, guys. So this is what I wanted to kind of provide an understanding on, that what are the different data types. So what we covered basically are what are the different types of data, understanding Java is a strongly typed language, how we can declare and define data in a single line, how we can use the wrapper classes for the primitive types and see what are the maximum and the minimum possible values that it can store. Let's move on to what are derived data types. So in derived data types, what we basically do is we are storing one particular primitive type multiple times in a single variable. So as you can see in this case, we have defined a particular array of character type and we are storing multiple character data. As you can see, I'm storing a B, I, N, A, R and a Y. So individually each of them are character data, but what I'm storing is a collection of all these characters. So this is how we declare as well as define a character array, which is a derived data type. Then we have a string. String can again be defined as a character array, but it has a special treatment in Java, due to which when we are kind of creating a string, we don't have this requirement to create it in this fashion. We can directly use double quotes and write the content of the string. So each of these character is again a character data type. So string is also a derived data type. We can do this with any of the primitive data types. We can have arrays for each of them. So let's say we have the data type integer. So for integer we created an array, and what is that array is going to store? It is going to store integers, multiple integers. So in this case it is storing 0, 1, 2, 3 up to 9, and each of these value is not a character, it is a integer literal. So next I'm printing out what we stored in my name. So since my name is a character array, this is going to come up as binary, and then we are printing out the string that we declared here, and then we are printing out the integer array that we created here. So in this integer array, when we print this out, there will be an issue. We are going to get the memory reference where this data has been created, but we have to kind of discuss in our upcoming session why that is happening. This is out of scope for the current lecture. Moving on, we have user defined or custom data types. So I have created a small custom data type here. Let's say I have a requirement of storing cube data. So let's say there are thousands of cubes, and each of those cubes have few properties that we need to store. So it can have a length, it can have a breadth, a height, maybe a surface area, a volume. It can have some mass as well, and it can have a surface color. So it can be a blue cube, a green cube, right? So we cannot store all this kind of composite data in any of the data types that we have discussed thus far. So there comes the use case of custom or user defined data types. So class is one of them. Then we will also discuss what are interfaces, what are enumerations, and those will be discussed in upcoming lessons. So that's pretty much it for this particular session. Hope you had a great time, a fun time learning all these concepts. And if you haven't already done so, please do like and subscribe my channel and hit the bell icon. That helps me out a lot, that motivates me a lot. And see you in the next lecture. So bye for now.